Hello everyone, my name is Mark, and today I will be reporting about events in probability. Just to give a clarification, I'll be only discussing what the events are and their operations. I'll not be going further into the topic. So let's get into this. Sir, sorry again that the footage got corrupted, and this took so long to make. But I think it'll be alright. Okay, let's start. Events in probability. What are events? In probability theory, an event is an outcome of a defined collection of outcomes of a random experiment. Since the collection of all possible outcomes to a random experiment is called a sample space, another definition of event is any subset of a sample space. Now, there are four different types of events. Mutually exclusive events, complementary events, exhaustive events, and independent events. Now, what are mutually exclusive events? These are events that could not happen at the same time. So, these events are separate. They cannot change each other. So, here's an example. On a die, a 4 is rolled, and when rolled again, a 5 is rolled. As you can see, they are both different events with completely different outcomes. So they are separate. They cannot do anything to the other one. So the mathematical meaning here is the probability of A intersecting with B would be equal to 0. Because as you see, they're separate. They're not crossing, they're not interfering with each other. Next, complementary events. These are events that have only two outcomes, like flipping a coin. One coin, to clarify. A head is flipped when you toss the coin once, and then when you do it again, a tail is flipped. As you can see here, since there are two possible events in one set of events, meaning our mathematical meaning would be the probability of A plus the probability of B would be equals to 1, because you can only get one event at one time. Independent events.
Exhaustive events, events of a random experiment, and are said to be exhaustive if at least one of them necessarily occurs. Example, rolling a die, sample space 1, 2, 3, 4, 5, 6. A. Getting even number equals 2, 4, 6. B. Getting odd number equals 1, 3, 5. C. Getting prime number equals 2, 3, 5. The events AB are exhaustive events because when a die is rolled, it results at least one of events A or B. AUB equals S. The events B, C are not exhaustive because they encompass the entire range of possible outcomes.
The occurrences of an event does not affect the probability of occurrence of other events. So they are within a certain set of events, but they are independent. They cannot affect the other event that would happen directly. For example, Justin goes to school using the bus. Mary goes to school on foot. Justin is traveling on bus. Mary is on foot. Probably when they go to school they would meet eyes, but the events would not affect each other because they are going at different ways. Here is an example. Here's a Venn diagram example of that. The square around the circle, or the plane where the Venn diagram is drawn, is the sample space, representing all our variables. So the mathematical meaning here would be the probability of A intersecting with B is equals to probability of A multiplied with the event of B. That we would be using multiplication of probability. Now, there are two rules in probability theory. One is the addition rule, one is the multiplication rule. Now, what is the addition rule for probabilities? The addition rule for probabilities describes two formulas, one for the probability for either of two mutually exclusive events happening and the other for the probability of two non-mutually exclusive events happening. The first formula is just the sum of the probabilities of two events. The second formula is the sum of the probabilities of two events minus the probability that both will occur. Mathematically, the probability of two mutually exclusive events is denoted by probability of y or z is equals to probability of y plus the probability of z. Mathematically, the probability of two non-mutually exclusive events is denoted by probability of y or z is equals to probability of y plus probability of z minus probability of y and z. Example: consider a die with 6 sides and the chances of rolling either a 3 or a 6. Since the chances of rolling a 3 are 1 in 6, and the chances of rolling a 6 are also 1 in 6, the chance of rolling either is 3 or 6 is 1 out of 6 plus 1 out of 6 is equals to 2 out of 6. Since we can divide it and bring it to the lowest term possible, we get 1 over 3. The multiplication rule. The multiplication rule is a way to find the probability of two events happening at the same time. This is also one of the AP statistics formulas. There are two multiplication rules. One is the general multiplication rule, which is P probability of A intersecting with B is equals to probability of A and probability of B divided by A, and the specific multiplication rule is probability of A and B is equals to probability of A multiplied by the probability of B. Probability of B divided by A means the probability of happening given that B has occurred. You have a cowboy hat, a top hat, and an Indonesian hat called songok. So these are examples. You also have 4 shirts: white, black, green, and pink. If you choose one that hat and one shirt at random, what is the probability that you choose the songkok and the black shirt? The two events are independent events. The choice of hat has no effect on the choice of shirt. There are 3 hats, so the probability of choosing the songkok is 1 out of 3. There are 4 different shirts, so the probability of choosing the black shirt is 1 out of 4. So by the multiplication rule, songkok and the black shirt is equals to 1 over 3 times 1 over 4 is equals to 1 over 12. And that will be all for this video. Thank you for watching, and I will see you next time. Bye.